Okay, so now let's do the next question. Find the Z transform and ROC of the signal. X of n is equal to 1 by 3 into n square plus n into 1 by 2 raised to n minus 1 u of n minus 1. Okay. So here, if you look at this question very carefully, here there is u of n minus 1, and here also that same n minus 1 is also over here. That is 1 by 2 raised to n minus 1. Okay, so here there are both n minus 1 shift. Same n minus 1 shift is taking place in these two terms. That is 1 by 2 raised to n minus 1 and u of n minus 1, right? So from here itself, you can understand what you need to do. This itself should be a first clue to what you need to do first. As first you need to do is you need to find the Z transform of 1 by 2 raised to n u of n. Okay, after finding the Z transform of 1 by 2 raised to n u of n, then you need to apply the time shifting property. So because when you apply time shift, if this signal is being time shifted by 1 second, then this signal will become 1 by 2 raised to n minus 1 and u of n minus 1, because time shift means then every value of time will be shifted by minus 1, right? Every value of time. Here n is the value of time, n represents time, right? So if I shift the function by 1 second, then every value of n that you see here in this equation will be shifted by 1 second. So here this n will become n minus 1 and this n will become n minus 1. So that's what you see here. In other words, the best way of applying this Z transform of this is to find the Z transform of this function and then apply the time shifting property to this function. Then you'll get the answer. Then you'll get partial answer. Then after that, you need to apply the multiplication by n property 2 times, right? 2 times you need to apply the multiplication by n property, and then with that answer you multiply with by 1 by 3, and that is your final answer. Okay, so let's do this problem. So first what I'm going to do is, we know that the Z transform of u of n, Z transform of u of n is equal to 1 by 1 minus Z inverse. Okay, 1 minus 1 by Z inverse, right? It may be, if you want, and here the magnitude, we all know the magnitude of this is nothing but ROC is nothing but magnitude of Z is greater than 1. This I can also write it as Z by Z minus 1. Okay. So next what I'm going to do is, I'm going to apply the multiplication sequence, right? The multiplication sequence 1 by 2 raised to n. So here we know that also Z transform of a raised to n x of n, right, is nothing but x of a inverse z. Okay, and here the value of a is 1 by 2. In other words, Z transform of 1 by 2 raised to n x of n, right? X of n is nothing but x of 1 by 2 the whole raised to inverse z, and 1 by 2 raised to 1 minus 1 is nothing but 2, which means this is nothing but x of 2z. So which means that in order to find the Z transform of 1 by 2 raised to n u of n, in order to find the Z transform of 1 by 2 raised to n u of n, simply substitute every value of z over here with 2z, right? So this will become 2z by 2z minus 1. Okay, and what about your ROC? Here the value of a is 1 by 2, right? So if you apply multiplication sequence to x of n, the ROC will be multiplied by a. So here the original ROC is 1, right? Magnitude of z greater than 1. So 1 into a is 1 into 1 by 2, which is 1 by 2, which means the magnitude of z, or the ROC, is nothing but magnitude of z greater than 1 by 2. Okay. So now what I'm going to do is, now I'm going to apply my time shifting property, right? Now I'm going to apply time shifting property. So means we already know this is x of z, this is x of n, this is x of z, and we know that the Z transform of, we know that, let me write that also, we know that the Z transform of x of n minus 1 is nothing but z inverse x of z, z of x of n minus 1. That means replacing every n with n minus 1 over here is nothing but z inverse into x of z, which is, that means that z transform of 1 by 2 raised to n minus 1 u of n minus 1, right? Replacing every n with n minus 1. So this is basically means this one only, replacing the signal with or shifting the signal by minus 1 second. So this is nothing but z inverse into x of z. X of z is this value over here, so it is nothing but 2z by 2z minus 1. Okay, z inverse into z is 1, so which means your z transform is 2 by 2z minus 1, and the ROC is, there won't be any change, so magnitude of z is greater than 1 by 2. Okay, so now I found the z transform of this. Now I found the z transform of this equation. Now what I'm going to do is I'm going to apply multiplication by n sequence, multiplication by n property, right? So multiplication by n, and we need to apply that property 2 times, right? Because here usually, as you can see here, it is n square plus n. So that means you need to apply. So first you need to find the multiplication by n, the property, then you're going to apply multiplication by n square property and add these two z transforms. So which means first I'm going to, so first we know that is a transform of n x of n, right? N x of n is nothing but minus z d by dz into x of z, minus z into d by dz of x of z. Okay, here my x of n is nothing but this is sequence over here, or in other words, the z transform of n into 1 by 2 raised to n minus 1 u of n minus 1 is nothing but minus z d by dz of your x of z is nothing but 2 by 2z minus 1. Okay, and your ROC is same, right? So here now, so it means I need to differentiate this and then multiply this with minus z, which means this is nothing but minus z into, so I'm going to use u by v equation, that is v into du. V into du means here du is 0, so that is gone, and second term is minus of u into dv. U is 2 into, and your dv is again 2 itself into 2 by v square, which is 2z minus 1 the whole square. Minus of minus becomes plus, and this becomes 4z. So this is nothing but 4z by 2z minus 1 the whole square, and your ROC remains the same, right? So this is it, 4z by 2z minus 1 the whole square. Okay, so now I found the z transform of this. Okay, I have found the z transform of this. Now I need to find the z transform of multiplication by n square property, right? I need to find the z transform of multiplication by n square property. That is, we know that the z transform of n square of 1 by 2 raised to n minus 1, or okay, don't write that, z transform of n square x of n. Z transform of n square x of n is nothing but minus z d by dz the whole square of x of z. Okay, so this is the property. So here your x of n is 1 by 2 raised to n minus 1 u of n minus 1. Okay, that was I was supposed to write before. This is n square into 1 by 2 raised to n minus 1 u of n minus 1. Okay, n is nothing but minus z d by dz the whole square into, and your x of z is 2 by 2z minus 1. Okay, all right, so which means that you need to differentiate this and multiply it with minus z, then again differentiate it and then again multiply it with minus z. Okay, luckily you have already discovered what happens after when you differentiate it and multiply it with minus z one time. You get this value, right? You will get this value, or that means this is nothing but this is equal to minus z d by dz of 4z by 2z minus 1 the whole square, because you have already differentiated this and multiplied with minus z one time, right? So you don't have to do this process again. So you already found this. Now what I'm going to do is I'm going to differentiate this and then multiply it with minus z. So I will get here as minus z into, so differentiating this using u by v equation, so it means v into du, which is 2z minus 1 the whole square into u in v into du is 4 minus u into dv, u is 4z and your dv is 2 into 2z minus 1 into 2, and this whole thing is divided by 2z minus 1 the whole raised to 4. Okay, this is what you get. So here you can see 2z minus 1 is common, right, both in the numerator and in the denominator. So maybe I can take that outside and they get cancelled each other. So in other words, this is nothing but minus z of taking 2z minus 1 common, right, and that common and this denominator 2z minus 1 will cancel each other. So you will get over here as minus z into 4 into 2z minus 1, because this 2 will become 1, this power 2 will become 1, minus, and this 2z minus 1 will disappear. So you will have 2 into 2 4, 4 into 4 16 minus 16 z by 2z minus 1 the whole raised to 3. Okay, so this is what you get. So now I can just simply simplify this more and more. So this is because minus z into, this is 8z, 8 minus 16 is minus 8z, and then minus 4, right, minus 4, 8z minus 4 by, this is nothing but 2z minus 1 the whole cube. Okay, if you put the minus over here, this will become, the whole thing will become plus. Let me write that over here. So this becomes plus, so it will become z into 8z plus 4 by 2z minus 1 the whole cube. Maybe I can take 4 common, right? If I take 4 common, this will become 2z plus 1. So this is nothing but 4z into 2z plus 1 by 2z minus 1 the whole cube. Okay, and your ROC remains the same, right? So you got this, right? So now you got the answer. So what you're going to do is simply apply the, or simply add these two answers, right? Simply add these two answers, right? Because we know that the x of n, right, x of n is nothing but 1 by 3 into n square plus n, your given question, into 1 by 2 raised to n minus 1 u of n minus 1, right? Or this is nothing but 1 by 3 into, this is n square into 1 by 2 raised to n minus 1 u of n minus 1 plus n into 1 by 2 raised to n minus 1 u of n minus 1, right? So what you did is that I found the z transform of this fellow, then I found the z transform of this fellow, then what I need to do is add the z transform of these two answers and then multiply with 1 by 3, right? So this is the z transform of this person, right? And this is the z transform of this fellow over here. Okay, so now I'm going to do is I'm going to find the z transform of these two answers by simply adding these two. That's all. So that means your x of z is nothing but 1 by 3 into, let me write that over here so you will understand better. Z transform of n square into 1 by 2 raised to n minus 1 u of n minus 1, okay, plus the z transform of n into 1 by 2 raised to n minus 1 u of n minus 1, okay. So what is the z transform of 1 by, let me write 1 by 3 into, okay, so what is the z transform of n square 1 by 2 n minus 1 u of n? You found the value, that is this one over here, right? This is the value, so that is nothing but 4z into 2z plus 1 by 2z minus 1 the whole cube, okay, plus, and what is the z transform of this function? That also you have found over here, right? That is 4z by 2z minus 1 the whole square plus 4z by 2z minus 1 the whole square, okay. So now then add together using LCM, right? LCM means you don't have to do anything, just simply multiply this function with the, multiply this numerator with 2z minus 1, right? Multiplying the denominator numerator with 2z minus 1 the whole 2z minus 1, then this denominator will become 2z minus 1 the whole cube, same as this, and here it will also be multiplied with 2z minus 1. So you will get over here as x of z, that means x of z is equal to 1 by 3 into 4z into 2z plus 1 by 2z plus 1, or sorry, minus 1 the whole cube plus, this is 4z into 2z minus 1 by 2z minus 1 the whole cube, or this is nothing but 1 by 3 into 4z into 2z plus 1 plus 4z into 2z minus 1, the whole thing divided by, since the denominators are now same, 2z minus 1 the whole cube, okay. This is nothing but 1 by 3 into, this is 8z square plus 4z plus 8z square minus 4z by 2z minus 1 the whole cube. This 4z and this minus 4z will cancel each other. 8 plus 8 becomes 16. So your final answer is 16z square by 3 into 2z minus 1 the whole cube. This is your final answer, okay. And as for your ROC, let me check what about your status of your ROC. This is your first ROC, and then after applying this multiplication by this exponential sequence, your ROC became like this, and then you applied n over here. Time shift does not change your ROC. Multiplication by n also does not change your ROC. Multiplication by n square also does not change your ROC. Therefore your ROC is the same. It's nothing but magnitude of z is greater than 1 by 2. Okay, so this is your final answer. Okay.